I'm back with another one, and in this one we are going to take a look at my frame. I was getting a lot of questions in my review videos and my fleet overview videos about this actual frame, and I'm going to take a look just at the frame, and I'm going to tell you everything about it since its beginning. And this was the actual first frame I did. It was 2016, and I have the link to the thread on the forums going over the frame itself. Well, let's go over the frame and iterations during those few years. So let's start with 2016. In 2016, I think that was around the time that the Impulse RC came out with its original alien frame, and I like this frame a lot, but there were a few things that I didn't like, and I made basically my own alien frame. It was a bit narrow. It took almost the same arms. I mean, the whole pattern and the mid plate with the PDB was from the alien frame, but the top and bottom were actually different. I was always the fan of the vertical RX and VTX mounting. So on the one side that was place to place your RX, and on the other side there was a place for VTX. On the alien, I think the suggested build was you somehow zip tie the VTX to the back portion of it, and I thought it was a ridiculous way to mount the hardware inside. And on the top plate, I actually did something different. The frame was really light. I think it was sub 100 gram frame, because it was using somewhat flexible carbon fiber sheets that I reinforced with this kind of double plates where it needed. So if you were to place your GoPro, you had really thick and thick piece of carbon fiber to accommodate that. And also, when you hit something, you usually hit with this front prop portion, and it was really thick. The vibration back then weren't the issue. I mean, it resonated a lot. I mean, this is 1.5 or maybe 2 millimeter plate of carbon fiber, and back then, well, the flight controllers were not that sensitive to vibration, and flew really good. So this was, I think, the first version of the frame that I designed, or rather made changes to existing frames to accommodate what I would like in my frame. So I think this was called Invasion X. Also, there are that frame underwent some changes. It made the bit more stylized cutouts on the bottom plate, and something different. But this shape of the arm, or rather bottom plate, would play a role later in the evolution of the frame. So this actually when the ICM gyros became a thing, would be better for vibration transfer than this shape. Also, this became relevant when the first KISS flight controllers became a thing, and this was really bad for the vibrations. I mean, really bad is not that bad. It was really better than all other frames, but for me and the way I take approach on building the quads, this was significantly better. Also, in 2017, I made an effort and made another frame that was from the ground up built and had nothing to do with any other frame on the market, and it was basically called the Dream because it was my dream frame. And it also underwent major changes from basically this was the first version of the Dream to get to this. So let's go over the changes. It also had the very thin bottom plate because the arms was the main carrying structures to all of the hardware. Basically, it was the racing frame, and you know all the racing frames are basically the pods in the middle with the arms extended, and that was my idea. It has really beefy center and arms, and all the portions that are not in the center are basically the carrier for the VTX camera, VTX and RX and the Gopro. So in crashes, I wasn't concerned about the front and back because basically you weren't able to hit the center structure anyhow, but the arms. So arms were what were taking all the energy of the impact, and yeah, basically I made it really thick, and there were 4mm arms, and this version had something really unique, and I didn't saw anything that were quite like this. This was actually laser edged. The Dream, this is not the sticker, it's laser edged and painted inside the carbon. So this was something that I really liked, but yeah, it was painstaking to paint the carbon fiber, and yeah, it was just one of a kind. So for this frame, I made also a drop deck version, because back then you were using the individual ESCs that were mounted on the arms, and basically you only had the flight controller, VTX and receiver that were in the frame itself, so you could get away with a drop deck version of the frame. And also when the ICM gyros and really sensitive gyros became a thing, the vibration also had the impact on the frame resonance. Also, I made an effort and made these braces that were stiffening up the carbon fiber and making them more resilient, but it also made the design really intricate. And yeah, maybe also there were front bumpers in case you took a crash in really low angle, it could impact the front, and also in the back I had the SMA vertical plate to accommodate the SMA and take antenna and the back, and this back portion was exactly the same width as the TBS Unify that I used at the time. So you just simply took the VTX in the back and run the SMA cable or pigtail to the back VTX or SMA holder and run your antenna from the back. Also back then the HS cameras were a thing, so this frame didn't have vertical camera holders, but rather the bracket that came with your HS camera just simply slotted from the bottom, and you screwed it down with this one screw, and you can slide it front and back, and you can adjust the tilt of your camera. So also I've already explained the drop deck version. It also had the Gopro Mount here, and this was a really thick piece of carbon fiber to have a lot of strength in this front portion, so you can carry your GoPro around. So, but in this iteration, and when the 4-in-1 or stack flight controller and ESC became popular, there was no need for thick arms, so you just had the wires for the motors running across the arms. I decided to do this. This is a 6mm arm, and really thin, basically thin as your motor wires, just the motor wire thickness. It was 7mm thick, and it had something really interesting. Back then I decided to use these cutouts for the screws. Basically, this is the 6mm arm that was chamfered to 4mm, so you can use your standard hardware that came for your 4mm for your 4mm standard size quads or arms. But also I took 1mm off this back portion, so it can use basically the same hardware that you were to use on all of this, so made it 4mm thick. But then again, this was really not the optimal option, because in the crashes you when you took the impact like so, the plate that was holding the arms together just digged under the chamfered piece, and they laminated the whole top. And also this design was actually prone to the twisting forces and were not that optimal. Take in mind, this was way better than any other frame out there, but due to my high standards, I decided to ditch this and made it the last version that I have and this is 5mm arms that are 10mm wide, because I like to use those iFlight channels for the routing the wires through them and protecting them during prop strikes. And also the arm shape changed because there were actually the motor standard became 16x16, and the whole pattern just needed that. Also, to get back into this arm, the bottom holes and holes in the top are actually different. They are designed to accommodate 3 screws, because you had 18x18 and 16x16 hole pattern, and you simply did your 16x16 and one 80 millimeter, so you can really grip the motors with just more than just 2 screws, because there aren't a lot of, or became the standard, the 16x16 hole. This arm has only 16x16 hole pattern, and as I explained previously, the arm shape is oval. When you take the impact to ground, I mean, those pointy arms are going to crack, break or something, but these arms are just chipping away and don't break, because the shape is this, or rather the force is distributed along the much more wider area and doesn't break. Also, I find very useless those arms that are extending too much and claiming to protect the motors. I mean, if you take the impact to the ground, you will always impact with the carbon fiber first, and to protect the motor bell, I mean, you have the prop here, and it's really no way you will impact the motor bell without the prop. Well, the prop is actually what's saving your motor, but in the case of frontal impact like so, I mean, there's no way the carbon fiber here will protect your motor. It will impact, just slide the I mean, whatever it is to one side, or even the prop will not allow the something hitting your motor. So basically, it's pointless to have arms sticking out in front, claiming to protect your motors, that are actually not true and not protecting your motors in any shape or form. So these, I mean, I'm flying these the first actual frame, the Invasion had this type of rounded arms, and I'm not going to tell you that this design is really proven and really great. So for the last, or the current version of the frame, I mean, I went over the arms and our arm mounting. The arm mounting is basically 2 screws. There's a washer inside the frame that actually aligns all the arms together, and you have this hole and this hole protecting the holding the arms in place, and in case you need to change the arm, there's only one screw that you need to unscrew, and just pull the arm out and replace it with another. So that's for the arm mounting. You have the two screws that I mentioned. There's 1 and 2, and this center one aligns the arms together, and this is what actually holding the arms. There's also a bracket here that holds the soft mounted screws for your stack. You can do 20 by 20 or 13.5 by 20.5 hardware. Also we have the bottom plate that's in this case 2.5 millimeters thick. The reason for that thickness is actual vibration properties, or the lack of vibrations in this frame. I mean, this is one of the stiffest frames you can find. To get back to this version of the frame, the actual frame was narrow to maybe to the point of where the arms meet. So basically something like this. But in that case, black box logs were worse than if you had this thicker piece of carbon fiber around the center. So basically the slightly thicker arms and a lot of material around the center portion made it really stiff. I mean, you can't really bend this frame at all. I mean, it is something is the stiffest frame I ever tried, and also I tried to do something more to the arms, and also I made this dead cat version of the frame. If you are more into cinematic type style of flying, and you were to use more lower angles and get the props out of the view, and also made it, I mean, it's stiff as it is, like so, but the same carbon fiber thickness, and also the brace here makes this, I mean, that you can move. I mean, I used the vise and tried to bend it, and it was nearly impossible. So no force that motor generates on the tip of the arms cannot twist or make any motion on the arm transfer to the center. And even if you were able to do that, you have your soft mounted screws. So basically the flight controller or the stack never actually touches any part of the frame without the vibration dampening. So the vibration, so the flight controller or the stack screws are completely isolated. There's no hard point of touching the structure of the frame that was to transfer to the stack. So again, to go over the bottom part, since we are currently in HD era of the FPV adventure, this frame cannot hold, I mean, it's really slim and tiny, cannot hold your standard air unit, but the back portion has your holes, 20 by 20 holes, to accommodate Vista HD system. You just simply put it here and run your antenna from the back, and also you have a 120 by 20 stack if you are going to use maybe the ESC here, your flight controller in front and your vista here, or maybe you will use something, I don't know, VTX here or anything. But the way I'm building it, I will show you that later. But let's go over the top plate. The top plate has the battery pad that I use or cut from URV Pad Star battery pad. I mean, this is the battery pad, basically copy of the UMA grip, and this is the laser cut pad from that material, and it's, I mean, best I could find. The reason it lacks the material here is the way you just run your strap through those slots, and that keeps the battery or straps from moving. But you also have these tips that prevent from strap from sliding, and you will just use one battery strap because the grip that holds the battery really tight. It doesn't allow the battery to slip, and you just place the battery here and you connect your XT60 here, and that's really compact way of securing the battery here. So you don't need to run your or zip tie your XT60 cables to the standoffs or something. You just get your battery here and run your XT60 down, and it's really secure. There are actually two ways or two mounts for your GoPros. This one is for your GoPro Hero 7, and it has the carbon fiber insert to protect the screen from impact. I mean, from the impact of the battery. I had my GoPro hit the wall, and the battery weight just impacted on the back portion, and I actually broke the GoPro, but not the lens, because you have this thick material around the lens, and not the screen. The screen didn't break. I broke the battery. The cells were damaged, but I actually managed to crack the GoPro in the middle here. So I bent actually the PCB inside the GoPro. So the lens and the LCD were unharmed, but the unfortunate GoPro was dead. So yeah, to the point of mounting, if you were to fly the low angle on the GoPro, you were getting the props in view. I mean, that's not impossible with this kind of arm mounting, but the really low angles that are used for your cinematic flying, you will need to have these that get arms, and that will remove the props from you in your low angle flying. Also, I have rather interesting options of mounting your XT60. This is the 3D printed back portion of the frame. You just simply slot the XT60 here and your antenna here. If you're flying Crossfire, maybe you have the front front mounts, or these ones, for your crossfire antenna that goes across here, and that is the ideal mounting on your antenna, because when you mount the antenna on the nose, in many cases the antenna is always in the view when you're flying farther away from you. So if you have your antenna on the back, maybe in some cases the GoPro, the battery will obstruct the view to the antenna, and maybe cause some issues. But when you have your antenna here, I mean, there are really small types of cases that the antenna will be obstructed by something. So let's go over the hardware I will going to use on my latest build, and I will show you how I will mount everything up. Just let me take the frame apart. So this is a hardware I'm going to use, and I'm not going to actually build it right now, but I'm going to make a review of the new Hobbywing F7 convertible flight controller, and I already have the 60 amp Hobbywing ESC review up, and this is the by far the best hardware you can use. I mean, this 60 amp ESC is really solid. I don't know how you would, what you need to do with it to burn it up, or this new, I mean, the quality and the build quality of this, and I mean, there's unparalleled with anything else on the market. And since I'm using Ghost ecosystem, I have the new Duo Fusion board that I'm going to use. But let me tell you how I'm going to implement it all. I already mentioned the Vista holder on the back. You simply use this back portion of the frame to mount your hardware here. There are two antennas for your RX signal that I simply run on the arms, one here and one here, and I use pigtail on the back, and simply run the UFL connector to the back, and you run your connector to the stack. Because the arms are that thick, the controller here or the board here is actually really not in line with the stack. So I simply use the supplied screws in here, and as you can see, the wires and everything clear the bottom portion of the board. If you were to run the Vista, you will need to solder the battery lead wires at a 90 degrees to get them over towards the top plate, and the wires would clear the Vista on the back. Only downside of this stack is that it's not actually stackable without the spacer. If you were to stacked one on top of the other, the top part here would actually not clear the part here. So I'm using little O-rings to clear the stack, and just to you have these small holes here that you use to screw the screws into the mount here, and also I use the standard 2405 motors that actually are in line with the arm tips. So the 2405 motors have the same shape as the arm tips, so it makes it super clean. So basically that's it for the frame, and I just cut the wires here and soldered them at a 90-degree angle here, so that everything clears the top plate. And this is the way I have my dream setup here in modern age. I mean, it went from 2016 to this current version without any major modification. I mean, the only thing that changed this version of the Dream, the first version, was a straight check. It wasn't perfect True X arms mounting bit, because I was firm believer of the the arm or the cam angle I was using at the time was really steep, and in forward flight the props had clean air, front and back props had a clean air around them, and it was a breeze to fly. But my flight style changed with time, and I used less of an angle on my cams. I mean, this is 35 degrees in this case. Even with the super view, you can view the props. You don't have the props in view at the 35 angle degrees. But if you use less of an angle, you need to have this cinematic version of the Dream, so you can fly it slowly. And if you still want to rip it around, you have your True X style of arms that in this 35 angle you don't have any props in view. And I mean, yeah, I don't know what to add, or yeah, let's come to an end to this video. So yeah, this is the latest version of the Dream that has True X arm mounting. It can accommodate every current stack that you can find on the market. Is it 20 by 20 or your standard mounting? If you would use 20 by 20, you have your screws and holes for that. You can accommodate Vista in the back, so it's HD ready, and you have one more 20 by 20 mounting pattern here in the front. If you would use something like 20 by 20 flight controller in front, the ESC in the middle, and VTX combo in the back, it makes it really low here. So yeah, that's it. That's it for the video. In the next one I'm going to make a video review of the Hobby Wing stack and build up the Dream from the bare bones. So yeah, stay tuned.